So this morning I'm going to go through section P5, and it's a friendly section. It's a section on multiplying, and with multiplying, unlike with adding and subtracting, we don't have to worry about like terms. So when I look at a problem like number 2, this is a multiplication problem because there's not a sign between the 8 and the parentheses, so that means multiply. You can multiply any terms. You can't even terms that you couldn't add. So you could not add or subtract the two terms here that are being multiplied, for the factors, I suppose, because they're not like terms. In order to add or subtract, you have to have the same variables with the same exponent. But that requirement's dropped for multiplying. And for multiplying monomials together, we multiply the numbers together and we multiply the letters together. The letters we multiply by adding the exponents. The numbers we just do generic multiplication. So in problem 2, what I need to do is I need to multiply the 8 and the 4. Put a little dot there for times. And I don't need to do anything to the x cubed because there isn't another x term to multiply by the x cubed. And for the multiplying, I'm just going to get 32x cubed. It's just that easy. Multiplying monomials, you multiply the number parts by the number parts, the letter parts by the letter parts, and for the letters, you add the exponents for the multiplication. 4 I could do, without showing any work, but I'll show the work. I'm going to rewrite the problem with the -9 first, because multiplication is commutative. You can always switch the order of any multiplication problem. And then it might be more clear that it makes sense to multiply the -9 and the 5 together. Now I wrote the problem without parentheses. It still means multiplication. Neither of these two steps are steps that I would normally show. Usually I can look at a problem like this, a single multiplication of monomials, and write down the answer without showing any kind of intermediate work. So the answer to this problem is going to be -45, because -9 times 5 is 45. I wouldn't do anything with the y. It needs to be part of the answer because it's in the original problem. It doesn't need to change because there's not another y to multiply it by. And that's all there is to that. So up through 16, the problems should be reasonably straightforward. In problem 6, now both the monomials that are being multiplied have both numbers and letters. You multiply the numbers together and the letters together. I can rewrite this problem in any order without the parentheses as long as I have just straight multiplication. So this problem is the same as 12 times 4 times y cubed times y. And you'll notice that for the letters I didn't put times sign, it still means times. So it's that problem that I wrote is equal to the original problem. Multiplication is commutative, which means you could change the order of the multiplication in a multiplication problem without affecting the result, and it might make it easier to see what needs to be multiplied. So in this problem, I'm going to multiply the 12 and the 4. I could do that without my calculator, but you certainly can use your calculator if you're not good at your times tables. And then for the letters, I have to add the exponents, and the y that didn't have an exponent written, there's an implied 1, and when I add those exponents, I get a y to the 4th. And that's all there is for that problem. I'm going to do the same for number 8. Then I'm going to deal with fractions, and you can use your calculator to multiply the fractions if you care to, but you don't have to. If you're good at working with fractions, you can work out them just by hand. So just like I did with problem 6, I'm going to rewrite this so I can show the things that are being multiplied together. And again, in any problem that only has multiplication, you can rewrite the problem, ordering it in any way you care to order it, and the parentheses in this problem were just there to signify multiplication, so dropping the parentheses and still doesn't change the problem because it's still a multiplication problem. Almost ready for my answer. if I could multiply 2/5 times 10/3 without my calculator, I would. But if you need to use your calculator, you can just break it out and do the fraction of 2/5, arrow out of the denominator, hit a times, and then fraction 10/3. My calculator tells me that part of my answer is going to be the number 4/3. And then the part that I don't need my calculator for are the x's. Just like the problem above it, the second x has an implied exponent of 1. And when you're multiplying with letters, you add the exponents. So that's the answer. It would have been nicer if I did the fraction multiplication by hand, meaning cancel then multiply. To get that 4/3 by hand, I'd cancel this 5 with that 10. The 5 would turn into a 1 when I divide it by 5. The 10 would turn into a 2 when I divide it by 5. And then what I have left in the numerator is a 2 times 2, which is going to give me this 4. And what's left after I cancel on the denominator is a 1 times 3, which will give me that 3. You really should be able to do basic fraction work like that by hand, but it's not going to be crucial on the test. You're always allowed to use your calculator to do any of the fraction work that you need to do. For that matter, anything that this calculator has the ability to do, you're allowed to exploit that ability and use it on the test. 10's a little bit tricky. I'm going to write it emphasizing that each of the y's, when they don't have a number written in front of them, there's an implied 1. The first y really has a positive 1 because it doesn't have a negative sign. The second y really has a negative 1. When I go to rewrite this, kind of like I've been doing, I can write 1 times negative 1 times y cubed times y. Now I'm going to multiply the 1 and the negative 1, and 1 times negative 1 is negative 1. And I'm going to add the exponents on the y's. Second y has an exponent of 1. And I'd get an acceptable answer for this would be negative 1y to the 4th. It would be better if I didn't write the negative and I didn't write the 1 and I just wrote negative y to the 4th. Negative y to the 4th is equal to negative 1y to the 4th, and it's less stuff to write, so it's somehow considered better. Do the similar thing for 12. Looks like a lot harder problem. We've got multiple letters and fractions. I'm going to write it in a nice order. The nice order is going to be 2/7 times 14/4 times x from the first parentheses, x from the second parentheses, y/4 from the first parentheses, y from the second parentheses. I'm going to do my fraction by hand, but you certainly can use your calculator. By hand on my fraction multiplication, I'm going to go cancel the 7 with the 14. 7 divided by 7 is 1. 14 divided by 7 is 2. And then I'm going to cross cancel the 2 with the 4. 2 divided by 2 is 1. 4 divided by 2 is 2. And I've done all the cross canceling I can do. I can still up and down cancel. So I'm going to cancel these 2's. I'm going to cancel this 2 with this 2, which is going to turn each 2 to a 1. And what I have left in the numerator is 1 times 1. What I have left in the denominator is 1 times 1. This is going to be 1/1, so the multiplication is just going to give me the number 1. I don't have to write that one, and I probably shouldn't write that one. If you needed to do it by hand, with your calculator, I'd go fraction 2/7, arrow out, times fraction 14/4. And my calculator tells me it's 1. So again, you should get comfortable doing fractions by hand, but if you can't, it's okay. Generally, we don't write a coefficient if it's a 1, but it's okay to write it. So I'll probably, right after this, write an answer that I think is a better answer. And this is going to be an acceptable answer, but the 1 is probably not the best thing to write. Done with the hard part. For the x's, neither of the x has an exponent, so there's implied 1's. And I add the exponents on the x's and get an x squared. For the y's, the second y has an implied exponent of a 1. When I add the exponent on the y's, I get a y to the 5th. So 1x squared y to the 5th is a good answer. Just plain x squared y to the 5th is a better answer. Just I thought I made a mistake earlier. I was thinking about a problem that I did, but it's right. Okay, for 14, I'm going to write the 3 and the x from the first parentheses, and then the x cubed from the second parentheses, and then the t squared from the first parentheses, and the t fourth from the second parentheses as my rewrite without the parentheses. It's not like a deal breaker if you don't write it, but it's nice to start writing equal signs in front of your work, which means this, what I wrote, equals the line above it. It looks different, it's written differently, but it's equal to the line above it. And now the 3 is not going to have anything to multiply by, so it's just going to be part of my answer. So part of my answer is going to be the number 3. I'm going to add the exponents on the x. The first x didn't have an exponent written, so there's an implied 1. And I'm going to add the exponents on the t's. 16, I'm going to rewrite without the parentheses, and the second parentheses, I'm going to consider that as a negative 1y. Sometimes it helps me to see the ones, sometimes I don't need the ones. It's never wrong to put the ones in. If you need them, put them in. So when I rewrite 16, I'm going to write 2/7 from the first parentheses times negative 1 from the second parentheses times y fourth from the first parentheses and y from the second parentheses. Now I'm going to do this multiplication. I could do that without my calculator, but if you need that, your calculator, fraction 2/7 out of the fraction times negative in the parentheses 1. My calculator tells me that's negative 2/7. And you have some flexibility as to where you put the negative. My calculator left the negative right in front of the fraction. You could put it in the numerator with the 2, or you can put it in the denominator with the 7. Either having the negative in front of the fraction or in the numerator is more common. So in my answer, I have a tendency to bring the negative up to the numerator, but it certainly would have been equivalently fine if you wrote it like that for the number part. And then for the y part, I'm going to add the exponents. The second y has an exponent of 1, and I'll pick up a y to the 5th. You do need the negative. It either can be written to the left of the fraction or in the numerator. It also could be written in the denominator, but that's really unusual. Generally, we wouldn't write a fraction with just a negative in the denominator. Okay, so ready to do the next kind of problem. In the next kind of problem, I'm multiplying a monomial, which is what's left of my parentheses. In the first case by a binomial, but some case by trinomials and other polynomials. To do the problems between 17 and 36, I have to multiply what's in front of the parentheses by both of the monomials inside the parentheses. So it's going to be a little bit more involved. So for 18, I have to multiply 4y times 2y cubed, and I also have to multiply 4y times negative 3. Usually I'd put a plus sign between these. Actually, usually I'd get to the answer without showing any steps, but if I'm going to show the multiplication separately, then the results of the multiplication, a plus sign is a fine thing to put between them. Now I'm going to get a little bit lazier and start doing the multiplication without rewriting it, because I'm good enough at it at this point where I don't need to rewrite it. The first multiplication, I'm going to multiply the 4 and the 2 and pick up an 8. And I'm going to add the exponents on the y's. The first y has an exponent of 1, the second y has an exponent of a 3, and I'll get y to the 4th. For the second multiplication, I'm just going to multiply the 4 and the negative 3 and get negative 12. I could write plus negative 12 and then carry the y down. The y doesn't change in that second multiplication. That's a correct answer. If you're going to write the answer this way, usually when you have two signs next to each other, you separate the signs with a parentheses. This is an okay answer, but honestly it's odd to see plus a negative, because a plus a negative is the same as a minus. So this would be a better and more common answer. If I wrote ay to the fourth, 8y to the fourth minus 12y. And you can't go further with this, because to go further these would have to be like terms, because to subtract both the letters have to have the same exponents, and because they don't have the same exponents I can't go any further. In problem 20, I need to multiply the 5 by the negative 3x and the 5 by the negative 7. So I'm just going to write down what I'm going to multiply by, and I'm not going to worry about the signs until I go to my answer. So I'm going to multiply 5 times negative 3x, 5 times negative 7. When you multiply the 5 times the negative 3x, the only thing that you're really multiplying is the 5 and the negative 3. The x is going to be part of that multiplication result, but it's not going to be affected. So I'm going to get in for an answer here, a negative 15x. And this multiplication gives me a negative 35. I can write plus a negative 35, kind of like I did here, plus a negative 12y, or I can just write a minus 35. And minus 35 is probably better to write. So again, the alternative answer, that probably isn't as desirable, but if I was doing this with a plus sign between, I could have said plus negative 35. So a lot of times I don't show this sign between the terms, because that kind of leads me to things that sometimes I don't want to write. I just show what I'm multiplying and then figure out what the answer should look like after I do the multiplication. 22 is written oddly, and I can rewrite it so it doesn't look so odd. I can rewrite it with the 2y first and the 3y to the fourth plus 5 second. That certainly looks more like I'm used to, and multiplication is commutative, so you can always change the order of any multiplication problem. And whether or not that 2y is in a parentheses, the answer, or what I'm going to do next, is going to be the same. So whether you leave the parentheses or drop the parentheses, that's completely up to you. What I need to do is multiply the 2y by the 3y to the fourth and the 2y by the plus 5. When I do 2y times 3y to the fourth, you multiply the 2 and the 3 together to pick up a 6, and you add the exponents on the y's together to get a y to the fifth. The other multiplication I needed to do is I need to multiply 2y times positive 5. I don't need to put a positive sign with that 5. If I just put a 5 there without a sign, it means it's positive. And in that multiplication, you just multiply the 2 and the 5 and get a positive 10. The y stays unchanged. And I have to have a sign between those terms, and there certainly isn't any reason to put a negative sign because that multiplication didn't give me a negative, so I'm going to put a plus sign between them. So the best answer for 22 would be 6y to the fifth plus 10y. You can't get a 16. You can't add the 10 and the 6, because in order to add with letters, the letters have to have the same exponent. They have to be the same letters too. If it helps for 24, I can rewrite this as 4x times negative 2x plus 1. You can always switch the order of any multiplication problem. And now I'm going to go 4x times negative 2x and 4x times 1. For the first multiplication, I have to multiply the 4 and the negative 2, and I have to multiply the 2x's. The 4 times negative 2 is going to give me negative 8. I'll add the exponents on the x's and pick up an x squared. And the second multiplication, anything times 1 is itself, so 4x times 1 is going to be a positive 4x. I'll put the sign between the terms and have an answer. That's as good as any answer I can write. It's can't be simplified more. You can't combine the -8 and the 4 because you can only add or subtract. Now it's an adding problem. You can only add or subtract when not only do you have the same variables, but the variables have the same exponent. If this x didn't have an exponent, then I could combine them. Or on the other hand, if that x had an exponent of 2, then I can go from the 2 terms to the 1 term. 26, I'm just going to multiply, because I don't really need the equal sign when I show the steps like I'm showing them. If I don't put the plus sign in between the multiplications, then I probably shouldn't put an equal sign. But if I would have written -3 times 4x plus -3 times -9, then it's actually equal to the line above it. But if I don't put that sign between it, that's not really equal to the line above it. That's probably over picky in terms of when not to use an equal sign. First multiplication, I multiply the -3 and the -4 and get a -12. Carry the x down. Second multiplication, -3 times -9 is positive 27. Always have to put a sign between the terms. Since it's positive, I'm going to put a plus sign. And that's the best I can do. That's my whole answer. (28), I'm going to multiply -4b times b squared. And then I'm going to multiply -4b times 3b. And then I'm going to multiply -4b times -7. For the first multiplication, the b's, you add the exponents, and the -4 just stays along. Somebody get -4b to the 3rd power. Second multiplication, I multiply the -4 and the +3 and get a -12. That's going to allow me to put a negative sign between the first two terms and the number 12. And then for the b's, I add their exponents and get a b to the 2nd power. And then the last multiplication, I multiply a -4 and a -7 and get a positive 28. I bring the b down. I have to have signs between my terms. Because this is a positive 28, I'm going to put a plus sign between my terms. And then that's the best I can do for an answer to 28. Hopefully, you're working at a pretty good clip here. And if you feel good about a certain group of problems, you could just do the problems ahead of me or skip to the next group of problems. Ultimately, you should try to do every odd problem in a section, but you don't have to watch me do every single problem. So if there's something that's just easy for you, you can definitely skip over my gibberish and move on to the next kind of problem. On the other hand, if something's just mind-boggling to you, you can always rewind and watch something over and over again. Maybe watching something a second or a third time will make it make sense. Likely, watching something 3 or 4 times, if it doesn't start to sink in, then you're going to need to come visit me and have me explain something differently. This stuff is kind of basic right now, but we get some trickier stuff as we get into the course a little bit. Not particularly hard, but just a little bit trickier than this. And if you just can't understand what I'm doing in a video, I usually know other ways to explain a problem, and you can always come visit me and I can teach you a different way if you don't like the way that I show, if I know a different way. Generally, when I record the videos, even if I know 4 different ways to do a problem, I only do one of the ways, because sometimes if I show 2 or 3 ways, students start to kind of blend the easy parts of each of the methods into something that just doesn't work. So, and I've had bad luck doing problems more than one way, so you'll only see me do things one way for the most part, even though there might be other ways that you might even find easier. 30, I have to go 4/5 times -3x, and I have to do 4/5 times 15. I'm comfortable enough multiplying fractions, I don't need my calculator, but I'm going to do the 4/5, forgot the negative here, times the -3. And my calculator tells me that's a -12/5. Again, you have some flexibility with what you do with the negative. I like putting it in the numerator. So I'm going to write negative 12/5 and carry the x. If I was doing this multiplication and I didn't have a calculator that did fractions so nicely, I would put the negative 3 over 1. I'd multiply the 4 times negative 3 and get the negative 12 that I'd put in the numerator, or put the negative sign to the right of the fraction. And in the denominator, I'd multiply the 5 times 1 to get the 5. And then in that first multiplication, the x just kind of hangs around. It doesn't change because there wasn't an x to multiply it by. The second multiplication, they're both positive, so I'm going to get to put a plus sign down. And if I wanted to do it, because I couldn't do it in my head, I'd go 4/5 times 15, and I'd get plus 12. So the answer to this is going to be negative 12/5 x plus 12. I don't need to get a common denominator because these terms can't be combined by adding, because they're not like terms. The first term has an x, the second term doesn't. To do that multiplication to get that 12 by hand, I'd write the 15 over 1. I'd cross cancel the 5 with the 15. 5 divided by 5 is 1. 15 divided by 5 is 3. Then in the numerator, I'd multiply the 4 times 3 and get a 12. In the denominator, I'd multiply the 1 times 1 and get a 1. I'd get 12 over 1, and 12 over 1 is equal to 12. For 32, I'm going to go negative 2/3 times 7x and negative 2/3 times negative 6. Again, I could do the ugly fraction work on my calculator. First multiplication is I used the wrong negative. So you have to use this negative for a negative number. So fraction negative 2 over 3 times 7. My calculator tells me that's negative 14 over 3. So the first piece is going to be negative 14/3 x. Again, if you want to do that multiplication by hand, you'd write the 7 over 1. Then you'd first multiply the negative 2 times 7 and get a negative 14. And then you'd multiply the 3 and the 1 in the denominator and pick up a 3. Second multiplication is multiplying two negatives, so I should get a positive. The second multiplication is going negative 2 over 3 times negative 6, which gives me a 4. So I don't even get a fraction for the next multiplication. So after the negative 14/3 x in my answer, I'm going to put a plus, then a 4. If I was doing this without my calculator, I'd write the negative 6 over 1. I'd cancel the 3 with the negative 6. 3 divided by 3 is 1. Negative 6 divided by 3 is negative 2. Then in the numerator, I'd multiply negative 2 times negative 2. In the denominator, I'd multiply 1 times 1. The negative 2 times negative 2 gives me a positive 4. The 1 times 1 gives me 1, and 4 over 1 is equal to 4. Ugh. Sorry about the number of problems, but I just want you to get comfortable doing this kind of multiplication, because this is kind of the basis of the rest of the section. So here I have to go 2x times 5x cubed. I have to do 2x times negative 6x squared. I have to do 2x times minus 7x, and 2x times 1. First multiplication, you multiply the 2 and the 5, which gives me a 10. You add the exponents on the x's, which are 1 and 3, which is going to give me a 4. Second multiplication, positive 2 times negative 6 is negative 12. I add the exponents on the x's, which are 1 and 2, which gives me an x cubed. Third multiplication, I multiply 2 times negative 7 and get negative 14. Add the exponents on the x's and get an x squared. Last multiplication, anything times 1 is itself. I'll get a positive 2x. That's all there is for that. That's much straightforward and easier than 36. In 36, I have to go 5/6x times 8x cubed, and then 5/6x times negative 12, and then 5, 6x times 3x, and 5, 6x times 7. This is supposed to be a 6 here. First multiplication, I need to do 5, 6 times 8, so 5 over 6 times 8. My calculator tells me that's 20 over 3. So I'm going to write 20 over 3 for the coefficient from the first multiplication. And then I'm going to add the exponents on the x's and get an x to the 4th. If you wanted to do that fraction multiplication by hand, you'd write the 8 over 1. You'd cancel the 6 with the 8. 6 divided by 2 is 3. 8 divided by 2 is 4. Then you'd multiply the 5 and the 4 to get the 20 in the numerator. You'd multiply the 3 and the 1 to get the 3 in the denominator. Second multiplication, I have to multiply 5, 6 times negative 12. And I forgot the x squared part of this, but it needs to be there. Just forgot to write it. And so to do 5, 6 times negative 12, I'll go 5 over 6 times negative 12, and I get negative 10. So for the second piece, I'm going to have negative 10, and then the exponent on the x is going to be 3. If I want to do this multiplication of the fractions by hand, I'd write the negative 12 over 1. I'd cancel this 6 with that negative 12. 6 divided by 6 is 1. Negative 12 divided by 6 is negative 2. Then I'd multiply the 5 times negative 2 in the numerator and get a negative 10. The 1 times 1 in the denominator and get a 1. I get negative 10 over 1, which is negative 10. Third multiplication, 5 over 6 times 3 gives me 5 halves. So in my answer, I need a positive 5 halves. And then I'm going to add the exponents on the x's and get an x squared. To do that multiplication, 5, 6 times 3, I'd write the 3 over 1. Cancel the 6 with the 3. 3 divided by 3 is 1. 6 divided by 3 is 2. Then I'd multiply the 5 times 1 in the numerator, the 2 times 1 in the denominator, and that'd take me to the 5 halves. Last multiplication is 5 over 6 times 7, which gives me 35 over 6, and that's going to give me positive 35 over 6x. Just to save time, I'll skip the showing you how to do that by hand. And that's the answer for 36. The next group of problems is multiplying binomials. And to do binomials, you multiply by foiling. So I'm going to do my foiling here. First thing I'm going to do is multiply the 5x times the 6x. That's considered, we call that the firsts, because 5x is the first thing in the left parentheses and 6x is the first thing in the right parentheses. So part of my foiling is to multiply the first thing in each parentheses. And then we do something called outers. Now the 5x is kind of outside left and the 4 is outside right. So now we can consider the outers of this, 5x times 4. I'm done with the 5x. The next part of foiling is the inners, and the negative 2 and the positive 6x are kind of the insides of the parentheses. So we're going to do negative 2 times 6x. And then the last L in the FOIL means last. So FOIL is first, outers, inners, and lasts. And so to understand the foiling, this 5x is both a first and an outer. This negative 2 is both an inner and it's also last. The 6x is a first and an inner. The 4 is a last and an outer. And I'll do enough of these so you'll be able to know exactly what you multiply pretty quickly if you don't already, haven't seen this recently. And then to finish this up, I'll do the last, which is negative 2 times 4. Now I'm going to do my multiplications. First multiplication, I multiply the 5 and the 6 and get 30. I add the exponents on the x's and get an x squared. Second multiplication is a positive, so I'm going to put a plus sign. I'll multiply the 5 and the 4 and get 20. Leave the x alone. Third multiplication, multiply negative 2 times 6 and get negative 12. Leave the x alone. Last multiplication, negative 2 times 4, and you get negative 8. Usually, when you FOIL, the outers and the inners are like terms that can be combined, and that's the case here. So before I commit and say something's an answer, I need to add or subtract any like terms. That's terms that have the same letters with the same exponents, and condense them. The 30x squared doesn't have anything to add or subtract because there isn't another term that has an x squared. The 20x minus 12x is going to give me a positive 8x because 20 minus 12 is positive 8. And when you're adding or subtracting, the letters don't change. The minus 8 is going to be part of my answer. It's not going to combine with anything because there isn't another term that doesn't have a letter. That's it for 38. I have an answer that's acceptable. Now I'll go to 40. I'm going to go firsts, which are negative 5y times 3y. Outers, which are negative 5y times negative 2. Inners, which are 8 times 3y. And lasts, which are 8 times negative 2. Basically, I take the first thing in the first parentheses, multiply it by both things in the right parentheses, then the second thing in the first parentheses, multiply it by both things in the right parentheses, and I just give them special names just so you make sure to get everything you need to get multiplied. First multiplication, I go negative 5 times 3 is negative 15. I add the exponents on the y's. Y times y is going to give me a y squared. Second multiplication, negative 5 times negative 2 is positive 10. I leave the y but don't change the y. Third multiplication, positive 8 times positive 3 is positive 24. And I leave the y. Last multiplication, positive 8 times negative 2 is negative 16. And just like the last problem, just like most foiling problems, the outers and the inners can be combined because they have the same variable with the same exponent. But the first and the last, they don't change, but they need to be part of the answer because there isn't anything else that has a y squared, or there isn't any other number without a letter. So I'm going to write the firsts, and then I'm going to combine the outers and the inners by adding the 10 and the 24, and then leave the last alone. And that's as far as I can go in terms of simplifying that, because you can't, now it's an addition or subtraction problem, you can't add or subtract unlike terms, and there's no like terms left. 42, firsts, 5 times 4y. Outers, 5 times negative 1. Inners, negative 3y times 4y. Lasts, negative 3y times negative 1. So the first, I'm going to multiply the 5 and the 4 and get a 20. Leave the y alone. The outers, 5 times negative 1 is negative 5. Inners, I'm going to multiply the negative 3 times the positive 4 and get a negative 12. And y times y is going to give me y squared. Lasts, I'm going to multiply negative 3 times negative 1 and get positive 3 and leave the y alone. This time it's the firsts and the lasts that can be combined. Those are going to combine to be a 23y. That needs to be part of my answer, but it probably shouldn't be written first in my answer because I should write the exponents in descending order. So in my answer, I'm going to take the negative 12y squared and write it first because it's the y term that has the highest exponent. So it actually says negative 12y squared. I'm not sure what it looks like. And then 20 plus 3y is going to give me 23y. And then I'm going to take down the minus 5. So that's writing my answer, and not so it's that readable, in a nice order with the correct terms. If you would have written it, 23y minus 5 minus 12y squared, if you would have changed the order up and wrote it in a less standard order, I wouldn't take points off. It's just not usually the way it's written. Usually you take the highest exponent term down to the lowest exponent term, or the constant term, the term without the letter. 44 is another foiling problem. And it's a foiling problem where the things that are going to combine might not be the outers and the inners, just because the terms are written in standard form. and because the 5 and the 4x are switched in the first parentheses, it's going to mess up probably what can be combined. So firsts, 5 times 7x, outers, 5 times 2, inners, negative 4x times 7x, lasts, negative 4x times 2. For the first, I go 5 times 7 and leave the x, get a 35x. Outers, 5 times 2 gives me a positive 10. Inners, negative 4 times 7 is negative 28. X times x gives me an x squared. Lasts, negative 4 times 2 is negative 8. And I pick up the x. Again, the things that can be combined here are 35x minus 8x. And 35 minus 8 gives me a 27x. I'd probably write that in the middle. I'd write the negative 28x squared first. I have to have signs between terms, and because this is positive, I'm going to put a plus sign between. Haven't written the positive 10, it's probably best to write it last. So my answer, at least the best answer I can write for problem 44, assuming I haven't made any adding or multiplying errors, is negative 28x squared plus 27x plus 10. 46, I'll probably break out my calculator. Firsts are 2/3 y times 1/3 y. Outers are 2/3 y times negative 5. Inners are 4 times 1/3 y. Lasts are 4 times negative 5. First multiplication, I have to multiply 2/3 times 1/3. I could do that without my calculator, but since I have it here, I'll go 2/3 times 1/3. And my calculator will tell me that that's 2/9. So for the first, the number part of my first is going to be 2/9. The letter part, I multiply the y times y and get y squared. For the outers, I have to multiply 2/3 times negative 5. And 2/3 times negative 5 is negative 10/3. So I'm going to write minus 10/3 and leave the y. For the inners, I have to multiply 4 times 1/3. And that gives me a positive 4/3. And for the last, 4 times negative 5 is negative 20. I certainly don't need a common denominator between all 4 terms. I do need to combine the outers and the inners. And to combine the outers and the inners, I have to be able to combine negative 10/3 plus 4/3, which is going to be negative 10 plus 4 over 3. On my calculator, I could do negative 10 over 3 plus 4 over 3. My calculator tells me that comes out to negative 2. That's because this whole thing equals negative 6/3, which is negative 2. So in my answer, I'm not going to make every fraction have the same denominator. The 2/9 y squared, because it didn't have anything to combine with, I'm going to leave it as 2/9 y squared. And then the y term in the middle, I'm going to write minus 2y, because when you multiply, or when you add negative 10/3 plus 4/3, you get negative 2. And when you're adding or subtracting, you don't get new exponents. The letters, the exponents stay put. It's only when you're multiplying do the exponents change. And then I'm going to bring down the negative 20. So the best answer for that is 2/9 y squared minus 2y minus 20. Ugh, sorry about this. Firsts, 2/5 x squared times negative 4/5 x. Outers, 2/5 x squared times negative 2. Inners, 3x times negative 4/5 x. Lasts, 3x times negative 2. So you could use your calculator to do the multiplication. The multiplication I have to do for the firsts, it would be a 2/5 times the negative 4/5. And that's just going to go 2 times negative 4 is negative 8. 5 times 5 is 25. And then I'm going to add the exponents on the x's. 2 plus 1 is 3, so I'm going to get a negative 8 25ths x cubed. Second multiplication I need to do is need to multiply 2/5 times negative 2. To do that multiplication, I'll write the negative 2 as negative 2 over 1. I'll go 2 times negative 2 is negative 4. 5 times 1 is 5. And when I do the outers, I'm going to leave the x squared just like it is. The fraction part of the inners, I need to multiply 3 times negative 4/5. I'm going to write the 3 over 1 and go 3 times negative 4 is negative 12. 1 times 5 is 5. And then the x times x is going to give me an x squared. The last, I'm going to multiply 3 times negative 2 and get negative 6 and leave the x alone. And these terms can be combined. To combine these terms, I need to be able to go negative 4/5 minus 12/5, which is going to be negative 4 minus 12 over 5, which is going to be negative 16 over 5. Again, I could do the fraction work on my calculator without the letters if I did negative 4/5, so clear fraction negative 4 over 5 minus fraction 12 over 5. My calculator would tell me I'm a moron, but I don't know what I did wrong. Oh, I didn't do a denominator, so negative 12 over 5. And you get negative 16 over 5 like I did by hand. So for all fraction work, if you are bound to your calculator, don't really care. But again, it's nice to be able to do it by hand. So for my answer, the negative 8 over 25 x cubed has nothing to combine with. It should be written first because it has the highest exponent. And then these two gave me a negative 16/5 for the coefficient. And when you're adding or subtracting, you don't change the exponent on the letter, so you get a negative 16/5 x squared. And I'm going to bring down the negative 6x. That's the best I can do for that problem. It's messy because the fractions, but again, you could do the fractions with your calculator, so they shouldn't be anything that keep you from getting, if it's on a test, 100%. Oh, more and more of these. On 50 and 52, I call these conjugate pairs. What makes these problems special is the parentheses have the same contents, except the signs are different. So that's what makes a conjugate pair. Two binomials that are the same except for the signs being opposite. And when you multiply in conjugate pairs, the outers and the inners will cancel. A lot of times I multiply these in my head and don't even show the foiling. But anytime I'm multiplying conjugate pairs, you can do a full-out FOIL, but you should expect your answer to not have the outers and the inners, because those always cancel when you multiply conjugate pairs. Again, a conjugate pairs, these are conjugate pairs because they're both parentheses have the binomial 4x with a 5, and to make them conjugates means they have opposite signs. But I can just FOIL this regularly and not even realize that these are special problems and still get the right answer. So first 4x times 4x, outers 4x times negative 5, inners 5 times 4x, lasts 5 times minus 5. First 4x times 4x is 16x squared. Outers 4x times negative 5 is a negative 20x. Inners 5 times 4x is a positive 20x. Lasts 5 times negative 5 is a minus 25. And like I predicted, when I go to simplify this after I FOIL, the outers and the inners are going to cancel because they're going to be opposites. They're the same term with opposite signs. So I don't write that in my answer. For my answer, I'm just going to have the firsts and the lasts. And that's always the case when you're multiplying conjugate pairs. that your answer is only going to contain the firsts and the lasts. It won't contain any more than that. So doing 52, if I just did the first and the last, I'd get the same answer as if I did first, outers, inners, and lasts. So if you're clever, if you recognize something as a conjugate pair, so I'll say over here, I'll say the clever way to solve. I've just done y times y firsts, and the lasts 3/2 times negative 3/2. Y times y is going to give me y squared. To do the last, I multiply 3 times negative 3 and get a negative 9, 2 times 2 and get a positive 4. That's the clever way to attack problem 52, because anytime you're multiplying conjugate pairs, the outers and the inners will cancel. The, not so clever way is to do full foiling. There's nothing wrong with not recognizing that I have conjugate pairs here. You can go firsts, y times y, outers, y times minus 3/2, inners, 3/2 times y, lasts, 3/2 times minus 3/2. So it'll take me more work, but I'll get to the same answer. For the first, y times y is positive y squared. The outers, I'm just going to write those in a different order. I'm going to write the minus 3/2 and then the y. When I'm multiplying just a number times a letter, I just leave them written next to each other with the appropriate sign. The inners, I'm just going to put a plus sign. I'm going to leave the 3/2 and the y next to each other. And the last, I'll go 3 times negative 3 is negative 9, 2 times 2 is 4. And as I knew was going to happen, the outers and the inners are opposites, and when I go to combine them, they're going to cancel, and I'm going to be left with an answer that just has the first and the lasts. So this only works when the two parentheses have both different signs, but everything else the same, where you can be clever and just do the first and the last. That's the only time you get conjugate pairs. If both parentheses had 2 minus signs in these problems, or both parentheses had 2 plus signs, then you'd have to do the full foiling. There wouldn't be conjugate pairs, and the outers and the inners wouldn't cancel. Ugh, sorry about these two. Section is getting a lot longer than I thought it was going to be. To do problem 54, I just have to multiply everything in each parentheses by everything in the other parentheses. So I have to multiply the 3x in the first parentheses by each of the 3 terms, by the x squared, by the 5x, and by the 3 in the second parentheses. Now it doesn't really have a foiling acronym to it, it's just do it. Multiply the first thing in the left parentheses by all 3 things in the right parentheses, and then the second thing in the first parentheses by all 3 things in the right parentheses. So I'm going to go negative 2 times x squared, negative 2 times 5x, and negative 2 times 3. I'm going to do my multiplications, and I'm going to start writing things vertically, kind of like we did in the last section, just to make the like terms easier to see. First multiplication, 3x times x squared gives me a 3x cubed. Second multiplication, 3x times 5x gives me a positive 15x squared. Third multiplication, 3x times 3 gives me a positive 9x. Fourth multiplication, negative 2 times x squared gives me a negative 2x squared. And rather than writing it right after the 9x, I'm going to write it under the 15x squared because it'll make it easier to see the simplifying. You don't have to. You could write it after the 9x. Just when I stack them vertically like this, which is acceptable to do, it makes it easier to see the terms that combine. Fourth multiplication, negative 2 times 5x is negative 10x. I'm going to write that under the negative 9x. Last multiplication, negative 2 times 3 is negative 6. I'm going to put that nice vertical line like we had in the last section. I'm going to bring down the 3x cubed. And then 15x squared minus 2x squared is a positive 13x squared. and then 9x minus 10x is a negative 1x because 9 minus 10 is negative 1, and I bring down the negative 6. This is an okay answer. It's better if I don't write that 1 in front of the x. So it'd be better if I said this is 3x cubed plus 13x squared minus x minus 6. So the next, all the way up to 70, the problems are going to be big multiplication problems. And when I get big multiplication problems, I start taking advantage of being able to write things vertically to combine like terms. 56, I need to multiply the y by each thing in the parentheses that it's next to. So I'm going to go y times 2y squared, y times y, and y times negative 4. And then I'm going to do the same thing with the negative 2. I'm going to go negative 2 times 2y squared, negative 2 times y, and negative 2 times negative 4. First multiplication, y times 2y squared is going to be 2y cubed. Second multiplication, y times y is plus y squared. I'm going to sneak the 1 in front of it because it might make it easier on the next step. Third multiplication, y times negative 4 is negative 4y. Once I get to the next group of multiplication, I'm going to start doing things vertically. Next multiplication, negative 2 times 2y squared is negative 4y squared. And then negative 2 times y is negative 2y. And then negative 2 times negative 4 is positive 8. Have my things ready to go now. 2y cubed has nothing to combine with, so it's just going to be in my answer as a 2y cubed. For these y squared terms, the numbers in front have opposite signs, so I subtract to take the sign of the larger and get a negative 3y squared. For the y terms, the numbers are both negative, so I add them and keep them negative and get a negative 6y, and I bring down the 8. So the important part here, these numbers are of opposite signs. You subtract and take the sign of the larger, which gives me a negative 3 for the y squared. These numbers have the same signs. I add and keep the signs. And after I do the multiplying, it's an adding and subtracting phase. In the adding and subtracting phase, you don't change the exponents. It's only when you're multiplying do you change the exponents. So 2y cubed minus 3y squared minus 6y plus 8 would be perfect. 58. I'm going to go 2a times 5a squared, and then 2a times negative 2a, and then 2a times negative 3, and then the same with the 3. 3 times 5a squared, 3 times minus 2a, and 3 times minus 3. First multiplication, I go 2 times 5 and get a 10, a times a squared and get an a cubed. Second multiplication, 2 times minus 2 and get a minus 4, a times a and get an a squared. Third multiplication, 2a times minus 3 is minus 6a. Fourth multiplication, I multiply 3 times 5 and get a positive 15, and I leave the a squared. Next multiplication, 3 times negative 2, I get a negative 6, and I leave the a. Last multiplication, 3 times negative 3 is negative 9. Again, I wrote things vertically to make the combining easier. Ready to get to my answer. Bring down the 10a cubed. In the middle here, the numbers have opposite signs, so I have to subtract, take the sign of the larger, and I get a positive 11a squared. The 6's both are negative, so I add them and keep them negative and get a negative 12a. And then I bring down the negative 9. So my best answer for 58 would be 10a cubed plus 11a squared minus 12a minus 9. I'm probably certain that I've made an error someplace in this video, so if you see me, and you know I did something wrong, shoot me an email so I can let everybody else know that I messed up, because doing this many problems without using my calculator, there's sure a danger of just screwing something up. Oh, too many of these problems. 60, I'm going to go 3z times 2z squared, and then 3z times negative 3z, and then 3z times 1. And then I'll do negative 2 times 2z squared, and then negative 2 times negative 3z, and then negative 2 times 1. First multiplication, 3 times 2 is 6, z times z squared is z cubed. Next multiplication, 3 times negative 3 is negative 9, z times z is z squared. Third multiplication, 3z times 1 is a positive 3z. Fourth multiplication, negative 2 times 2 is negative 4, leave the z squared alone. Fifth multiplication, negative 2 times negative 3 is positive 6, leave the z alone. Last multiplication, negative 2 times 1 is negative 2. Add them up. Signs are the same, you add. Signs are different, you subtract. Bring down the 6z cubed. For the z squareds, the signs are the same, so I add 9 and 4, keep them negative, and get a negative 13z squared. 3z plus 6z is 9z. Then I bring down the minus 2. So backwards, if you need to write it in the opposite order, you certainly can. You can write any multiplication problem in any order because multiplication is commutative, and for me it's easier to see like this. So now I'm going to go 4x times 3x squared, 4x times 5x, 4x times 3, negative 3 times 3x squared, negative 3 times 5x, and negative 3 times 3. I sense I'm picking my pace up because I'm just tired of doing these. I imagine you might be too. You don't need to watch me do every single problem in this grouping if you just know how to do it, and you can do the homework problem without watching every problem. First multiplication, I get a 12x cubed. Second multiplication, positive 20x squared. Third multiplication, plus 12x. Fourth multiplication, minus 9x squared. Fifth multiplication, minus 15x. Last multiplication, minus 9. Going to bring down the 12x cubed. For this combination, they have opposite signs, so I subtract. 20 minus 9 is 11, and I get a positive because the bigger number is the positive. Here, opposite signs again, so I'm subtracting. 12 minus 15 gives me a negative 3. I keep the x alone, and then I bring down that minus 9. So it should get 12x cubed plus 11x squared minus 3x minus 9 for my answer. Ugh. Oh my lord, this is really a bit extreme. So 8x times 2x squared and 8x times x, and then 8x times minus 1, and then 3 times 2x squared, 3 times x, and 3 times minus 1 are my multiplications. First multiplication, multiply the 8 and the 2, add the exponents on the x's, and get a 16x cubed. Next multiplication, 8x times x is 8x squared. Third multiplication, 8x times minus 1 is minus 8x. Fourth multiplication, you get a 6x squared. Fifth multiplication, I get a positive 3x. Last multiplication, I get a negative 3. For my answer, I'm going to get a 16x cubed that I bring down. Next one, they're both positive, so I'm going to add the 8 and 6 and get a 14x squared. Here they have opposite signs, so I subtract. 8 minus 3 is 5. The bigger number is negative, so this needs to be a negative, and then I bring down the 3. So 16x cubed plus 14x squared minus 5x minus 3 is good enough. Ooh, 66 is way long. I need to multiply everything in the left parentheses by everything in the right parentheses. It's going to be 9 multiplications. I'm going to start off with the 3x squared, multiply it by each of the 3 things. So I'm going to go 3x squared times 4x squared, and then 3x squared times minus 3x, and then 3x squared times 2. And then I'm running out of room. I'm just going to go under these in a second. I'm going to go 2x times 4x squared, 2x times minus 3x, and 2x times 2. So I'm done with the 3x squared. I'm done with the 2x. Now I move to the minus 1. I go minus 1 times 4x squared, minus 1 times minus 3x, and minus 1 times minus 2. Those are all the multiplications I can do. There's 9 of them. So I just did the 3x squared times all 3 things, the 2x times all 3 things, and the minus 1 times all 3 things. First, 3x squared times 4x squared gives me a 12x to the 4th. And then 3x squared times minus 3x gives me a minus 9x cubed. 3x squared times 2 gives me a positive 6x squared. So I've done this, this, and this. Now I'm going to start stacking. Next multiplication, 2x times 4x squared is a positive 8x cubed. Forgot the x here. I wrote 2x times minus 3 is supposed to be 2x times minus 3x. So this 2x times minus 3x is a minus 6x squared. And then the 2x times the 2 gives me a positive 4x. I'm going kind of fast, and there's a lot to do here. There's a big chance that I'm making a mistake. I'm trying to not, but I could. Now negative 1 times 4x squared is negative 4x squared. Negative 1 times negative 3x is positive 3x. Negative 1 times negative 2 is positive 2. So the nice thing about stacking is it makes it a lot easier to simplify after you've done all these multiplications. So for my answer, I'm going to have a 12x to the 4th, and then negative 9 and 8 gives me a negative 1 with an x cubed. It would be better if I didn't write that 1, but it's okay not to. The third string, the 6x squareds are opposites, so they cancel, and it leaves me with just with the minus 4x squared. The third addition gives me a positive 7x, and the last gives me a 2. So this would be an okay answer. Probably better if I didn't write the 1 in front of the x cubed. So that would also be a good answer. 68 is another monster problem. This would never make it onto a test because they take too long to do. So if you don't watch all this, it's completely okay. First, I'm going to go 2y squared times each of the things in the right parentheses. So 2y squared times 4y squared, 2y squared times 2y, 2y squared times minus 5. Then I'll start with the 3y. I'll go 3y times 4y squared, 3y times 2y, 3y times minus 5. And then with the minus 1 times 4y squared, minus 1 times 2y, minus 1 times minus 5. There's all 9 multiplications. Now I'm going to do them and stack them. First multiplication, I get 8y to the 4th. Second multiplication, I get positive 4y cubed. Third multiplication, I get negative 10y squared. Fourth multiplication, I get positive 12y cubed. Fifth multiplication, I get positive 6y squared. Seventh multiplication, I get minus 15y. Eighth multiplication, I get minus 4y squared. Oh, seventh multiplication. Eighth multiplication, negative 1 times 2y is negative 2y. Last multiplication, you get a positive 5. For my answer, bring down the 8y to the 4th. 4y cubed and 12y cubed is 16y cubed. For this next one, I need to go negative 10 plus 6 minus 4. I could do that without my calculator, but my mind is not working probably perfectly right now, so I'm going to break out my calculator to be safe. And that's going to tell me I need a negative 8 in front of the y squared. Third one, they're both negative. I add them and keep them negative, and bring down the 5. So my answer to 68 would be this 8y to the fourth plus 16y cubed minus 8y squared minus 17y plus 5, assuming I haven't done anything horrible and made a mistake. Ooh. Last one of these niners. So negative 2y squared times 5y squared, and negative 2y squared times negative 3y. Negative 2y squared times negative 2 for the first multiplication. Now I'm going to do the minus 5y. Go minus 5y times 5y squared minus 5y times minus 3y and minus 5y times minus 2. These are taking more room, so I'm just kind of just writing them randomly here, just so because I'm going to run off the page if I don't. Now I'll do the 3 and go 3 times 5y squared, 3 times minus 3y, and 3 times minus 2. So those are 9 multiplications. Now I'll do them one at a time. First multiplication, I get negative 10 y to the fourth. Second multiplication, I get positive 6 y cubed. Third multiplication, I get positive 4 y squared. Next, I get negative 25 y cubed, and then positive 15 y squared, and then positive 10y. Bottom row, 3 times 5y squared is 15y squared. 3 times minus 3y is minus 9y. 3 times minus 2 is minus 6. Combine all the like terms. Bring down the negative 10y to the fourth. 6 minus 25 gives me negative 19. When you're adding or subtracting, the exponents on the letter don't change. Next, 4 plus 15 is plus 34. Forgot to write the y squared there, I think. Yeah. And then 10 minus 9 is 1y. I'm just going to write the y without the 1. And the minus 6. You could have a 1 in front of that y. All right. Hour and 15 minutes already. Sorry about that. So 71 through 88, these are multiplying conjugate pairs. I call them differences of squares because that's the name they're going to get in chapter 1. And when I'm multiplying conjugate pairs, or quote-unquote differences of squares, I should only do the first and the last. So if you have 2 identical parentheses, one with a plus sign, one with a minus sign, doesn't matter if the minus sign's in the first parentheses and the plus sign's in the second parentheses, I can efficiently just do the first and the last. I could do foiling for this. If I did for 72, if I did foiling, I do firsts, outers, inners, and lasts. And if I don't take advantage of the differences of squares or conjugate pairs, I'm doing more work than I need to. Firsts are y squared, outers are minus 5y, inners are positive 5y, lasts are minus 25. And anytime you're multiplying conjugate pairs, or we can call them differences of squares, same binomials, one with a plus sign, one with a minus sign, the outers and the inners will always cancel. So for every problem between 71 and 88, these are conjugate pairs or differences of squares, and I should be efficient and just do the first and the last. Like that fool. I guess that's even appropriate because it's foolish to do it that way when you can just do the outers, the first and the last. So that was actually a good mistake because it's foolish to do that. And for the rest of the problems between 71 and 88, because they're conjugate pairs, and this is the only time I can skip the outers and the inners and the foiling, is when you have 2 identical parentheses with opposite signs, I'm just going to do the first and the last. So anytime I recognize I'm multiplying differences of squares, or also called conjugate pairs, you can just do the first and the lasts, and those I usually can do with just writing down the answer. I could have done the outers and the inners, but they would have canceled. The outers would have been a negative 12z, the inners would have been a positive 12z, and if I did them, they would have canceled anyways. So for every problem between 71 all the way up to 88, I'm just going to do the firsts and the lasts. to save time, and you should do the same. When you get to a problem, if you can recognize it as a difference of square or a conjugate pair, same binomial, one with a plus sign, one with a minus sign, you can just do the first and the last. If they both have minus signs or if they both have plus signs, you have to do the full-on foiling. So this is going to give me 9b to the 8th. You add the exponents on the number letters, minus 64. 78 is another conjugate pair, so I'm just going to do the first and the last. I'm going to multiply the y and the y, and the 4/5 times negative 4/5. When I multiply the y and the y, I get y squared. And when I multiply the fractions, I'm multiplying a positive times a negative, so I get a negative. And I multiply the 4's in the numerator together and get a 16. I multiply the 5's in the denominator together and get a 25. So it's just y squared minus 25. So the fractions, when you're in conjugate pairs, turn out not to be as intimidating as they could be. 80, again, it's a conjugate pair, so I only need to do the first and the last. The outers and the inners will cancel. First are 2x times 2x. Last are 3/4 times negative 3/4. The 2x times 2x gives me a 4x squared for my answer. The last are a positive times a negative, so I get a negative. I multiply the 3's, and I multiply the 4's and get a minus 9/16. 82, even though the x's are written second, it's still conjugate pairs because the parentheses have the same contents with opposite signs. So I do the first, which are 4 times 4, the lasts, which are 3x squared times minus 3x squared. The first give me a 16, the last give me a minus 9x to the 4th. This is an okay answer, but usually we write the letters first and the number without the letter second, so it would be better. But if you stopped there on a test, I wouldn't take points off. I might write under it, or you might have wanted to write it like this, but I wouldn't take points off from that. '84, '86, and '88 are all conjugate pairs because they're all binomials with opposite signs. Binomials with opposite signs, you just do the first and the lasts. For the letters, you add the exponents. Doesn't matter if the minus is in the first or the second parentheses. So for 84, I add the exponents on the y's and get a y to the 6th, and negative 4 times 4 is negative 14. These problems I usually don't even, I just write the answer. 86, the first are 2x times 2x, the last are negative 7 times 7. My answer is going to be 4x squared minus 49. And for all of these problems, you could do full-out foiling. Like on 88, if I wanted to go foil, I can go firsts, 7 times 7, outers, 7 times 3y, inners, minus 3y times 7, lasts, minus 3y times 3y. You can always multiply two binomials by foiling. That will always work. You can only shortcut it if you have conjugate pairs or differences of squares, which means you have the same contents but different signs. But had I foiled this, I'd gotten 49 plus 21y minus 21y minus 9y squared, and the outers and the inners are going to cancel. It always is the case when you're multiplying differences of squares, which you also call conjugate pairs, that the outers and the inners will cancel if you do foil. Now I'm going to write the two pieces that are left in a nice order, which means the number without the letter written last. Had you written 49 minus 9y squared, I'd be completely content with that as well. But I should have on 88 just done firsts, 7 times 7, lasts, negative 3y times 3y. That would have taken me to 49 minus 9y squared, which I could have written as 9 minus 9y squared plus 49 with a lot less work. So we need to be efficient when we can, because sometimes the problems get a little ridiculous. The next bunch of problems, the parentheses, I have the same contents with the same signs. You can't just do the outers and the inners. You have to do full-out foiling when the signs are the same. So firsts, y times y, outers, y times 5, inners, 5 times y, lasts, 5 times 5, that's y squared plus 5y plus 5y plus 25. So my answer is going to be y squared plus 10y plus 25. You notice when the signs are same, you can't just do the first and the last because the outer's and the inners don't cancel. 92, firsts, 2z times 2z. Outers, 2z times 6. Inners, 6 times 2z. Lasts, 6 times 6. Firsts are 4z squared. Outers are 12z. Inners are 12z, both plus. Lasts are 36. Outers and the inners don't cancel. They combine to be a 24z. So you can only skip the outers and the inners when the signs are different and the parentheses are exactly the same other than the signs. But if the signs are the same, you're locked into doing the foiling again. 94. Firsts. 3b to the 4th times 3b to the 4th. Outers. 3b to the 4th times minus 8. Inners, minus 8 times 3b to the 4th. Lasts, minus 8 times minus 8. First, I multiply the 3's, add the exponents on the b's, and get 9b to the 8th. Outers, I get a negative 24b to the 4th. Inners, another minus 24b to the 4th. They don't cancel because they have the same signs. You need one plus and one minus for them to cancel. The minus 8 times minus 8 is a plus 64. The outers and the inners, because the numbers are both negative, I'm going to add them and keep them negative. In my answer, I'm going to bring down the 9b to the 8th. I'm going to get a minus 48b to the 4th. When you're adding or subtracting, the letters don't change, just the coefficients change. And I bring down the 64. 96. Firsts, y times y. Outers, y times minus 4/5. Inners, minus 4/5 times y. Lasts, minus 4/5 times minus 4/5. Firsts, y squared. Outers, minus 4/5 y. Inners, minus 4/5 y. Lasts, I'm multiplying two negatives, so I get a positive. I multiply the 4 and the 4 and get a 16 in the numerator, the 5 and the 5 and get a 25 in the denominator. I need to combine the 2 minus 4/5, and my mind is mushy enough that I probably should break out my calculator and go minus 4 over 5 minus 4 over 5. My calculator tells me that's minus 8 over 5, and I probably should have been able to do that just fine, because when you have fractions with the same denominator, you just combine the numerators. The numerators are minus 4 and minus 4, which is minus 8. So for an answer to 96, it's y squared minus 8/5 y plus 16 over 25. Ah, more fractions. They actually cancel. Firsts, 2x times 2x. Outers, 2x times 3/4. Inners, 3/4 times 2x. Lasts, 3/4 times 3/4. Firsts are easy enough. 2x times 2x is 4x squared. To do the outers, I need to multiply 2 times 3/4. This will come out to 3/2. So I'm going to write plus 3/2 x for this. And this one's the same. It's 2 times 3/4 or 3/4 times 2. So I'm going to get another plus 3/2 x. And then for the last 3/4 times 3/4, I multiply the 3's and get a 9. I multiply the 4's and get a 16. Now I'm going to add 3/2 and 3/2 and get 6/2. So this is going to be 4x squared plus 6/2 x plus 9 over 16. And this 6/2 reduces to 3. So for an answer, I should write 4x squared plus 3x plus 9 over 16. Still a decent number of problems to do. Really a decent number. getting scarily long. I think I only have 15 minutes I can lecture and the video will shut off. So let me try to get through what I can and then I'll finish up on another video. Firsts, 4 times 4. Outers, 4 times minus 3x squared. Inners, minus 3x squared times 4. Lasts, minus 3x squared times minus 3x squared. 4 times 4 for the first, 16. Outers, 4 times minus 3 is minus 12, and I leave the x squared. Inners, minus 3x squared times 4 is minus 12x squared. Lasts, minus 3 times minus 3 is positive 9. I add the exponents on the x's and get x to the 4th. I'm going to combine these by combining the minus 12, and minus 12 and minus 12 combined together by adding will give me a minus 24. I'm going to write for my answer the 9x to the 4th first, and then the outers and the inners give me a minus 24x squared, and the last give me a 16. 102. Firsts, y cubed times y cubed. Outers, y cubed times 4. Inners, 4 times y cubed. Lasts, 4 times 4. This is going to give me y to the 6 plus 4y cubed plus 4y cubed plus 16. My answer is going to be y to the 6 plus 8y cubed plus 16. 104. Firsts, 2x times 2x. Outers, 2x times minus 7. Inners, minus 7 times 2x. Lasts, minus 7 times minus 7. Firsts are 4x squared. Outers are minus 14x. Inners are minus 14x. Lasts are plus 49. The outers and the inners have the same sign, so I add the numbers and keep the sign. For my answer, I'm going to get 4x squared minus 28x plus 49. I just peeked to make sure the video was still going. I need to lecture and not have it record. 106. First, 7 times 7. Outers, 7 times 3y. Inners, 3y times 7. Last, 3y times 3y. First are 49. Outers are 21y, positive. Inners are positive 21y. Last are 9y squared. I'm going to add these together to get a 42y. And I'm going to write things in a nice order, meaning the 9y squared to be written first. So for my answer, I get 9y squared plus 42y plus 49. (107 to 120) look like you can just do the firsts and the lasts, but anytime a binomial is written with a plus, with a square, you need to rewrite it without the square, because anything squared means to multiply that by itself. And these are FOIL problems in disguise. So all the problems between 107 and 120 are going to be foiling problems, because they're asking me to square a binomial. Each problem between 107 and 120, I'm going to write without the exponent. To write something without the exponent, if the exponent is 2, you have to multiply 2 identical terms. So now I'm going to FOIL. It's going to be 2x times 2x for my firsts. My outers are going to be 2x times 3. My inners are 3 times 2x. My lasts are 3 times 3. So this is going to be 4x squared plus 6x plus 6x plus 9. If I didn't rewrite it and I did the firsts and the lasts, I missed the 12x in the middle. My answer is going to be 4x squared plus 12x plus 9. So for every problem between 107 and 120, I'm going to start off by rewriting the problem without the exponent. And to rewrite a problem that has an exponent of 2 without an exponent, you need to multiply 2 of what's being squared. And that will turn each one of these into a FOIL problem, that you have to do the outers and the inners because the outers and the inners aren't going to cancel. So I wrote the problem without the square, made up of 2 binomials being multiplied, do my FOIL, which gives me a 16x squared plus 8x plus 8x plus 4. So my answer to 110 is going to be 16x squared plus 16x plus 4. If I don't do the rewrite without the exponent and I just do the first and the last, I'm only going to get the first and the last. I'm going to miss the outers and inners. I'm going to miss the answer. 112, I'm going to write it as 2x minus 3 times 2x minus 3. Do the firsts of 2x times 2x, the outers of 2x times minus 3, the inners of minus 3 times 2x, and the last minus 3 times minus 3. I'm going to get 4x squared minus 6x minus 6x plus 9. These don't cancel because they have the same signs. To add them, I'm going to combine them and get a minus 12x. Yeah, a lot of teachers and authors of textbooks break the stuff that I did today into 2 sections, and now that I'm doing this video, I kind of feel like I probably should have done the same. All the stuff fits real nicely together. It's all the same skill, but maybe this was too long for one section. It's tediously long, but hopefully it doesn't feel that hard. So for 114, I wrote it without the square, did my FOILing, and now the outers and the inners, because they don't have opposite signs, they don't cancel. They only cancel if there's one positive and one negative. When they have the same sign, you add the numbers and keep the sign. So the answer to 114 needs to be 16x squared minus 16x plus 4. My gosh. Having a lot of these isn't the worst thing, because this is a super common mistake that students at every level, even calculus students, will do this kind of problem wrong. So I think I put a few more of these than you probably really need just to hammer these down. So wrote it as without the exponent, FOILed, you get 16 plus 12z plus 12z plus 9z squared. Combine these, write it in a nice order. My answer is going to be 9z squared plus 24z plus 16. 118, I'm going to write it as 5 plus y times 5 plus y. Firsts, 5 times 5. Outers, 5 times y. Inners, y times 5. Lasts, y times y. So they give me 25 plus 5y plus 5y plus y squared. Write it in a nice order and combine like terms. I get y squared plus 10y plus 25 for my answer. My stack of paper is getting nice and short, so hopefully my video hangs on. Cool. 120 and 122, same deal. I'm going to make this 4 minus 3z times 4 minus 3z. These are not conjugate pairs. Firsts, 4 times 4. Outers, 4 times minus 3z. Inners, minus 3z times 4. Lasts, minus 3z times minus 3z. Firsts are a 16. Outers are a minus 12z. Inners are a minus 12z. Last are a plus 9z squared. Combine those to a minus 24z because they have the same signs. You add the numbers and keep them negative. write everything in a nice order. I'm going to get 9z squared minus 24z plus 16. 122, make this 5 minus y times 5 minus y. Firsts, 5 times 5. Outers, 5 times minus y. Inners, minus y times 5. Lasts, minus y times minus y. First, give me a 25. Outers, give me a minus 5y. Inners, give me a minus 5y. Last, give me a positive y squared. These don't cancel because they have the same signs. I'm going to add the 5s and keep it negative and get a negative 10y. For my answer, write it in a nice order with the y squared first, then the minus 10y, and then a plus 25. Next two problems just have multiple letters. Makes them a little bit hard, but not ridiculous. This is a foiling problem. So I'm going to do firsts, 5x times 4x, outers, 5x times minus 3y, inners, 8y times 4x, and last, 8y times minus 3y. 5x times 4x is 20x squared. 5x times minus 3y is minus 15, and I leave the xy alphabetically in order. The inners, 8 times 4 is 32. I leave the x and y next to each other alphabetically. The last, negative 8 times negative 3 is negative 24. Y times y is y squared. The outers and the inners have the same letters with the same exponents, so those can be combined. And I'm only going to take the numbers in front of them and change. When you're adding or subtracting, the letters don't change. I'm going to bring down the 20x squared. And for here, I'm going to go 32 minus 15 and get a positive 17. The x and the y are going to stay put. And then I'm going to bring down the minus 24y squared. (126) is multiplying a monomial by a binomial, so it's not foiling, it's just 5xy times 3y and 5xy times minus 2x. You only foil when each parenthesis has a binomial. Now I'm going to multiply in a nice order. I'm going to write this as 5 times 3 times x times y times y. That's going to give me a 15 and an x and a y squared. The second multiplication, I'm going to write down 5 times negative 2 times x times y, just grouping everything next to what it needs to be multiplied. The 5 times negative 2 is negative 10. The x times x is x squared, and then I bring down the y. These can't be subtracted because even though they have the same letters, the letters don't have the same exponents. So that's all I could do for 126. I'm done with that. 128 is not foiling again. It's just 3y squared times 2xy and 3y squared times 3x. Write it in a nice order. I'm going to go 3 times 2 times x times y squared times y for that multiplication. Just writing everything that needs to be combined together by each other gives me a 6x and a y cubed. And this one I'm going to write 3 times x times y squared. I get a positive 9 and then the x and the y squared. And I can't go any more with that because I can't add because the y's don't have the same exponents. 130 is a foiling. First is xy squared times xy squared. Outers. Oh, it's a foiling, but it's a conjugate pair. So I'm only going to do the first and the last. I'm being clever here. I could have done the outers and the inners, but because I'm multiplying two binomials with the same contents with opposite signs, I'm just going to do firsts and lasts and not do the foolish thing. I'm going to fix up this first multiplication. I'm going to go x times y squared. That's going to give me x squared, y to the fourth, and the last will give me a minus 25. I should probably say these are answers when I get down to the end. So you should always look for that when you're multiplying binomials if they have the same contents with different signs, you can take advantage of the shortcut. (132) and 134, there is no shortcut. I need to write them without the square, which means writing two identical binomials with the same signs. Now I have to FOIL. Firsts, 4x times 4x. Outers, 4x times minus 2y. Inners, minus 2y times 4x. Lasts, minus 2y times minus 2y. Firsts, I get a 16x squared. Outers, I get a minus 8, and I leave the x and the y intact. Inners, I multiply the negative 2 and 4 and get a minus 8. Write the x and the y alphabetically. Lasts, minus 2 times minus 2 is positive 4. Y times y is y squared. I'm going to combine these together by adding the negative 8s to get a negative 16. And when you're adding or subtracting, the letters stay the same. So I'm going to get 16x squared minus 16xy plus 4y squared. If the video happens to shut off, then the last few problems you're just not going to see, and you'll have to come visit me if you want to see me do them. 134, horrible problem, but I'm just going to write it without the square. So I'm going to get 5 minus 3xz squared times 5 minus 3xz squared. Firsts, 5 times 5. Outers, 5 times minus 3xz squared. Inners, minus 3xz squared times 5. Lasts, minus 3xz squared times minus 3xz squared. Firsts, 5 times 5 gives me a 25. Outers, I just multiply the 5 and the negative 3 and get a negative 15. Leave the xz squared intact. The inners, I multiply the negative 3 and 5 and get a negative 15xz squared. And then for the lasts, I'm going to multiply negative 3 times negative 3, x times x, and z squared times z squared. And that's going to give me a positive 9 for the two negative 3's, an x squared for the two x's, and a z to the fourth for the two z's. And generally, your outers and inners can be combined. That's the case here. The numbers in front of they're both negative, so I'm going to add them and keep them negative. And this would be an okay answer. 25 minus 30xz squared plus 9x squared z to the fourth. But this is a third degree term. That's a sixth degree term. That's a constant. It would be better for my answer if I wrote the terms in descending powers. So if I wrote 9x squared z to the fourth first, minus 30xz squared second, and plus 25 last, that would be the best answer, but the thing above it's fine. Almost to the end of this thing. Last two problems. 36, 136 even, I'd probably write in an order that I'm more used to because multiplication is commutative. You can switch the order. And now I'm going to go minus 7xy times 4x and minus 7xy times minus 3y. For this one, it's minus 7 times 4, and then the x's are multiplied and the y tags along. And you get minus 28 x squared y. Second multiplication, I go minus 7 times minus 3, 1x from the first, and then the two y's, one from each. I get a positive 21 xy squared. Those can't be combined to anything different because the exponents aren't the same on the letters. Last problem. FOIL. First, 3 times 5. Outers, 3 times AB. Inners, minus 2AB times 5. Last, minus 2AB times AB. The easy multiplication, that's just a 15. That's also easy. That's a 3AB. This is kind of easy. You just multiply the negative 2 and the 5 and get negative 10AB. The last one, I can write this as negative 2A, taking the A from the first and the A from the second, and BB, the B from the first and the B from the second, and you get negative 2A squared B squared. I'm going to combine the outers and the inners. The numbers in front of the outers and the inners have opposite signs, so I'm going to subtract those, take the sign of the larger, and get a minus 7ab. Now I'm going to write things in a nice order. So for my answer to the very last problem in this section, the highest power term is the minus 2a squared b squared, and then a minus 7ab, and then a plus 15. That's the best form of the answer. If you had written it 15 minus 7ab minus 2a squared b squared, it's completely okay. I'm not going to be picky on the test about the order. Hopefully you got through this in one sitting. If it took a couple sittings, I completely understand. If there's something I rushed too much, just let me know and I can explain it better personally to you or in class when you come to class.